In this video, I'll talk about how to name amines based on the IUPAC rules. So let's start out with this first structure that I got on the left side. So the first thing you always want to make sure you do is get the longest chain, and that would be considered an pairing chain in that particular case. So this one is really not does not really have anything on the other side of that nitrogen, just the hydrogen. So this is just in a primary amine. But I got this being the longest chain, and I want to make sure the amine gets the lowest number possible when you have the amine as the highest priority group. And in this particular case, I would number this as 1, 2, 3. So there's technically two ways of naming it. I can call it propane, because 3 carbon suffix is going to be propane, and then we end up with this called an amine. So the amine is at the first position, so I don't really have to specify one amine. If this was not at the first position, then I would have to specify the position of the amine. But you can also call this as propyl amine. So either one of those names are acceptable, but for the most part, I'm probably going to go with the first way of naming it, like propane amine, so that we can see the parent chain and we can have the functional group in there as well. So like for example, for the second one, I have an amine on the second carbon here, and then obviously I still don't have anything on the other side of the nitrogen, just the hydrogen, so it's still in the primary amine. But when I number this chain, I want to make sure I number from the left side so that the carbon that's connected to the nitrogen gets the lowest number possible. So this would be 1, 2, 3, 4. So for the 4 carbon chain, your suffix is going to be butane. And then the suffix for the functional group here is obviously going to be amine, but that's connected to the second carbon, so I'll call it 2-amine. So you typically get rid of the last letter on the alkane chain here. So you're not going to be putting E in there, but just leaving the E out because you're going to have some functional group suffix right after that. Let's look at this next one here. So in the next one, you can see how I actually have something else. I got 2 R groups on that nitrogen, and the third one is the hydrogen. So that means this is certainly in a secondary amine. But how do I really pick the longest chain or a parent chain? Your parent chain has to be the longest chain. So on the left side, I got 2 carbons, and on the right side, I got 1, 2, 3, 4 carbons. So when I make the right side as my parent chain, and then the other one is just going to be the substituents. So when I number this, I still want to make sure I get the lowest number possible on that amine here. So I would number it from here. That would be 1, 2, 3, and 4. So then whatever you have on that nitrogen, whatever R group is connected on that nitrogen becomes your substituents in that case. So this one would be N-ethyl, and then I got butane, and then on the second position I have an amine, so 2 and then amine. So that's how you really want to be naming those. Um, And then I can look at this aromatic amines. This is a very generic aromatic amine where you just have the nitrogen hooked up, or the NH2 hooked up with the benzene ring. The common name for this is going to be aniline. Make sure you know that. Okay, let's look at this next one here. So on this next one, I have um, it's a tertiary amine because I got an ethyl group here, I got an methyl here, and I got this long chain on the left side. So I want to make this as my parent chain, and then the other guys on the nitrogen will become or act like just the substituents. So when I'm numbering the main chain on the left side, I will start from the side so that the carbon that's connected to the nitrogen gets the lowest number possible. So I would number this as 1, 2, 3, 4, and 5. So now remember, I got a few things going on here in a sense that I have an methyl group here that's connected to carbon 3. I got a methyl that's connected to the nitrogen, and I got an ethyl that's connected to the nitrogen as well. So these has to be put in an alphabetical order. So like, your E comes before M, so I want to name the ethyl first. So this would be named as N-ethyl. And then after that, I have on the N position, I have a methyl, And then I also have on the third position I have a methyl, so that would be N-3 or N comma 3 rather dash dimethyl. And then your parent chain is going to be 5 members, so it's going to be pentane. And then I want to say the amine is connected to the second carbon, so that's going to be 2-amine. So that's how you want to name that one. Let's look at the one on the right side here. So this is a primary amine, so I don't have to worry about what's connected to the nitrogen, just the hydrogens here. And then I got the long chain would be 1, 2, 3. So I do have a chlorine connected to the second carbon here, so that would be acting as the substituent here. So that would be 2 chloro, and then it's going to be propane, and then I would have 1 amine. Okay, so that's simple so far. Let's look at this next one here. On the next one, I got 2 methyl groups, and then on the nitrogen, but your main chain is still going to be on the left side. That would be 1, 2, 3, and then I got bromine comes before the methyl, so I would say 2 bromo, and then I have N dimethyl, and then it's just going to be propane. And then your amine is at the first carbon. I don't have to specify it, so I can just call it propane amine. So I'll just move that to the left. Okay, let's look at this is an aromatic amine, which is an aniline. So I can call this an aniline, and I can number or call the rest of those guys accordingly. So aniline gets the priority, obviously, over these just the simple substituents you got, methyl, ethyl, or chloro, or anything like that. So I would number this as 1, 2, 3, 4, 5, and 6. So I got chlorine on the fourth position, so I want to make sure I put them in an alphabetical order. So 4 chloro, and then I got 3 methyl, and then I'll just end this with an aniline because that's just the common name for that particular aromatic amine there. Okay, let's look at maybe a few more here. I got this is going to be just a ring, cyclohexane ring. It's not a benzene ring, but out of the groups I got an amine and a methyl and a chlorine. Your amine gets the priority over those, so I want to make sure the amine gets the lowest number possible, and it will be treated as in a function group. So this would be 1 here, and then you want to count so that the rest of the guys gets the lowest number possible as well. So I want to count going toward the left here, so that's going to be 2, 3, 4, 5, and 6. I don't want to go to the right side because when I go to the right side, the chlorine and the methyl will get the higher numbers on that ring in that case. So I will still put those in the alphabetical order, however. So that would be 4 chloro, 2 methyl, and then, okay, this is going to be in a cyclohexane, and I can just call it amine. I don't have to specify, I don't have to say it's one amine because it would be automatically understood that if you don't specify the position of the function group, that means it is at the first carbon. This next one I got is a tertiary amine. I got an ethyl here and an ethyl here and an ethyl here. You could call this as just a triethyl amine. So that's just in a better way of naming it. When you have the same groups, same R groups on the nitrogen sides, just calling those with the prefix is better in that case. Now, what if you have like other function groups present in the molecule? Like for example, here I got a ketone and I got an amine. So then I got to worry about, okay, who gets the priority between those two function groups? Now, amines are typically toward the end in terms of the function groups. They do get better priority than the double bond and triple bond, but the rest of the function groups, they get better priority than the amines. So in this case, ketone gets the priority over the amine. So I want to make sure the ketone gets the lowest number possible and it acts as your function group. And what that happens to the amine then in that case, the amine becomes your substituent for that matter, because you cannot really have two kings, or you can say two function groups in this particular case. So one of them would be function groups and the other one would be the substituent, and that goes based on the priority. So this would be 1, 2, 3, 4. So now this is going to be just acting as a substituent. When amine act as a substituent, it's called an amino. So I can say this would be 4 amino, and then, okay, this is going to be butane as your parent chain. And on the second position, I have the ketone functional group. And remember what's going to be the suffix for a ketone functional group? That would be an ONE. So it's going to be an ON. Let's look at this one on the right side. On the right side, I got an alcohol, I got an amine. So between the amine and an alcohol, alcohol gets the priority. So this must act as a function group, and as a result, must get the lowest number possible. So when I'm numbering it, I want to start it from here, and then I also want to go around so that the next group gets the lowest number possible. So that would be 2 here, 3 here, 4, 5, and 6. So again, your amine would be just acting as your substituent. So I'll call that amino. So I'll call this 3 amino, and that's going to be just cyclohexane. And then the first position you have in an alcohol, so I don't have to specify, I do not have to say 1-ol. I can just say OL there. So cyclohexanol. Okay, we can look at this next one here. It's kind of similar. I got an alcohol in there. So that's going to get the priority. So this would be 1, 2, 3, 4. So that would be 4 amino. And this is going to be butane. Now I got to specify the position of alcohol because it's not at the first carbon. So 2-ol. Okay, let's try this next one. On this next one is a little bit more complicated because it got 3 groups on there. So then you got to look at the who is going to be the king, or who's going to have the top priority. So out of the aldehyde and an alcohol and an amine, aldehyde gets the priority. That means the other guys will act as your substituents in that case. So I want to make sure I get the aldehyde at the lowest number possible. So this would be 1, 2, 3, 4, and 5. So this would be called an amino as a substituent. Now OH also going to be acting as a substituent here, so that would be called an hydroxy. So when I go ahead and put those together, I'll want to make sure I go in an alphabetical order. So that would be 5 amino, 4 hydroxy, and then this is going to be pentane. And remember what's going to be the suffix for aldehyde function group? That would be Al. So I don't have to say 1-Al, that's because it's already at the first position. So this is how it's going to look like. If you have 2 amines, like this one here, I got 2 amines, then I can just count the carbons there. That would be 1, 2, 3. So I can just call it 1, 3 propane diamine. So whenever you have multiple nitrogen or amine groups, you don't take out the E. That's one of the things. And then the 1 and 3 are going to be the positions of your amines. I can also call this as propane and then 1, 3 diamine. So either one is fine. So that's the only thing. Like whenever you're using the prefixes in the amines, you don't take out the E for the parent chain. Okay, let's try this last one here. So I want to make sure I get the longest chain possible. And sometimes I want to make sure that I do get the amine function group in the longest chain. And even if it gets shorter, like for example, kind of seems like the top one is going to be the longer. If I count this as 1, 2, 3, 4, 5, 6, and 7. That's a 7 carbon chain here. But when I use this top one, I don't really get the nitrogen carbon included in the main chain. And that is the criteria. When you have a function group, I want to make sure I get the carbon or the function group carbon gets included in the main chain, even if it gets shorter. So that means your actual way of counting your numbering or finding the longest chain here would be 1, 2, 3, 4, 5, and 6. So I could have gone to the left side here. That would be the same thing. It doesn't really matter. Like I could have called this 3, 4, well, 4, 5, and 6, because whether you start from the bottom here, whether you go to the right side or to the left side, it's just the same carbon, so it doesn't really matter. So I want to go that way, so let me just go ahead and erase this out here. And then I want to say this right there becomes your substituent. So the substituent here is a 3 carbon chain that's going to be called propyl. So this, we would name this as 3-propyl, and then your parent chain is going to be hexane, and then your amine is at the 2nd carbon, so 2-amine.